This week, catching carbon, scannable snacks, and food made from thin air. Tick, tick. We've heard the warnings for some time. Tick.
They've been getting louder and louder.
The question is, has our time to act run out? Tick, tick, tick.
2020 was the joint hottest year on record.
Hurricanes and flash floods have battered the planet.
The Earth is in crisis.
And maybe, just maybe, this time, something will be done.
Next week, we'll be at the COP26 UN Climate Change Conference in Glasgow, where pressure is building on those in power to make big changes. And this is the first of 3 Click specials all about sustainability, what we can change and how much technology can help.
We all know plastic is a problem for our planet. Left unchecked, the ocean could contain more plastic than fish by 2050.
But much of the harm comes from things that we can't see so clearly, like the fossil fuels emitting greenhouse gases.
They currently emit more than 30 billion metric tonnes of carbon dioxide each year, and every bit of CO2 that goes into the air pushes the global temperature up just that little bit more.
And we can't just flick a switch, turn everything off and kill our emissions dead. So even to get to net zero, we're going to have to start sucking huge amounts of CO2 back out.
Dan Simmons and Nick Queck have been looking into carbon capture technologies to see if they really could help us turn back the clock.
For this film, we're focusing on CO2, the carbon that's produced mainly by burning fossil fuels and is the biggest contributor to rising temperatures. For decades, we've been able to capture carbon dioxide at scale at the source it's produced. In 2014, this was the first power station to use what's called carbon capture and storage. The flue gases are diverted to a purpose-built facility where the CO2 is stripped away in a chemical process. It's then compressed and stored 2 miles underground. More on how that works later. The system here stops around 2/3 of the CO2 from reaching the atmosphere. Last year, that was 750,000 tonnes. Other projects are even more efficient. So couldn't we just ramp this up a notch or two and solve climate crisis for good? Well, in theory, that would need tens of thousands more of these. And today, we have fewer than 30 worldwide, and sort of the same number again promised for the next 20 years. And it seems CCS, at least so far, isn't a big winner.
Despite concerted efforts over the last 2 decades, really, it hasn't taken off as a successful, economically viable technology at commercial scales. And that's because it's very costly. You can't fit carbon capture to the exhaust pipes of cars, for example. The technology just isn't downscalable to that sort of size.
So now another way to capture carbon is gaining ground. One that doesn't have to be where the pollution is created. In fact, you could put it in some of the cleanest parts of the world.
I've come to Switzerland to look at an exciting and relatively new way to clean up the planet's atmosphere. And it's being pioneered right here.
Climeworks is one of the companies hoping the answer to the great carbon cleanup is in the thin air around us.
These huge intake fans called collectors are sucking in the air from around them, and they're taking out the CO2. And because CO2 is around us everywhere, you can place these, well, pretty much anywhere on the planet. They can be cleaning up the environment.
Natalie Casas leads the team here. She moved from carbon capture to direct air capture after seeing expensive projects scrapped because of their cost.
So we have a two-stage process. In the first stage, we blow air through. CO2 sticks on the material. The purified air, so air without CO2 or with very little CO2, leaves the box. When the filter is full, we close the door and start heating. We heat up the collector up to 100 degrees, CO2 is released, and we take it out.
Once the filters are cleaned, the carbon capture can start all over again.
Pleasure for me to introduce you to our testing laboratory.
We're the first camera crew allowed into Climeworks labs, where they've been experimenting with thousands of materials to try to find the most effective at absorbing CO2 and at which temperatures.
Because nobody's interested to remove a bit of CO2. We are all interested in removing large amounts of CO2, millions of tons. So we have to rely on materials that can be produced in the large scale in a very short time. Our focus is showing the world we can remove CO2 from the atmosphere with a reasonable cost that can be improved in time.
There's some cause for optimism too.
This is one of the first collectors, and it takes out about 60 tonnes a year of CO2 from the atmosphere. Now, next year, the companies say they can reach triple that efficiency, 200 tonnes a year, and that bodes well for 2050.
By getting this capture plant to run on waste energy, its own carbon footprint is about 10 to 15% of what it's capable of removing over its lifetime. And Climeworks' biggest project to date, Orca, has just kicked into life last month in Iceland. It captures 4,000 tonnes of CO2 each year. The company sells the permanent removal of CO2 by weight. Even individuals can buy in. But in reality, it's mainly companies wanting to go green with a better environmental record.
At the time we decided to build Orca, we did not have the certainty from the market because simply it was not existing. So it was huge risk-taking for us. Already today, a large share of that capacity is contracted. And we are very thankful and happy that this happened. And that actually fuels and motivates us to keep going and actually already work on the scale-up of the next plant.
On a larger scale, companies such as Carbon Engineering are planning huge plants in northeast Scotland and Texas, which will each remove up to 1 million tonnes of carbon dioxide a year. But what of the carbon once it's captured? Nick Quegg is in Iceland, where a very green energy facility is leading the way.
This is one of the cleanest geothermal power plants on the planet, but it's also the testbed to some new technology which could make a huge difference when it comes to the global fight against climate change.
The Hetliside power station's emissions are being used by carbon capture and storage company Carbfix, that's turning CO2 to stone.
It comes in directly from the power station and it enters that tower from the bottom here. Then we inject cold water at the top and the CO2 becomes dissolved in water.
Crucial to the process is this giant oversized soda stream-like tower.
It makes sparkling water, and then it's ready to be transported to our injection site.
These metal igloos, or giant Christmas puddings depending how hungry you are, is where we start to get subterranean. Here, the carbonated liquid is forced 1 kilometre underground, where it meets the volcanic basalt rock.
Basalt has a lot of the metal that is required to permanently bind the CO2. So once it gets in contact with the basalt, it's going to form stable carbonate minerals where it will be permanently stored. So it is an ideal rock.
So this is the basalt rock in its natural form, incredibly porous for all the carbonated water to get in and fill every nook and cranny. And this, 24 months later, it crystallizes and forms calcite inside the basalt rock, and now it's pretty rock solid.
So you're looking to inject a lot of water into a lot of rock. Do you have enough rock to manage it?
Yes, so in Iceland alone, we have the potential to store thousands of gigaton in basalt here. And this is even before looking at the rest of the world.
For some industries, carbon dioxide isn't to be buried. It's a vital commodity.
This is beer which is being filtered, and it's about to go into either keg or bottle But this is where the CO2 is injected in line as it's passing along the pipe, and this is what makes the beer fizzy and carbonated.
Wye Valley Brewery in Herefordshire needs half a pint of liquid CO2 delivered for every pint they make. That's 3 million litres a year.
Without it, the beer would be completely flat and undrinkable, so CO2 is essential.
But if CO2 is all around us, shouldn't these companies be able to harvest it themselves? That's where these future-looking refrigerator-sized units come in from a new US startup.
We can provide CO2 for large food packaging plants, all the way down to a small machine there to pull the CO2 right out of the air from inside the restaurant or bar, right to the soda gun or the tap.
They do it by using these cubes with thousands of tiny holes through them. The whole thing is coated in a chemical that absorbs CO2.
As the air travels through, the tiny holes provide an enormous surface area, meaning a high proportion of the CO2 touches a surface and is absorbed.
Steam is then used to wash out the CO2, which is processed and stored, ready for local use. This can then start its work over again.
3 commercial trials are already underway, but this solution is relatively small beer. Perhaps one of the best technologies at solving the carbon problem is nature itself. I've come to Bryn Eye Wood in South Wales, one of the last patches of a once enormous ancient woodland. Today, a reforestation project is underway. Many countries have committed to planting more trees to soak up CO2, but my guide, Gwyn, says the mix of trees planted is crucial to success.
When there's a mixed amount of tree species within a forest, so the more biodiverse we have in terms of what's above the ground, the more biodiverse it is below the ground, and the more carbon ends up in the soil where it's stored for a very, very long time.
So does he think nature alone could lead us to carbon neutrality?
This is a recent plantation. There's around about 15 to 20 different tree and shrub species. This was planted about last year, last winter, which is a year ago now for us. But as you can see, they're really not getting anywhere above waist height. That really puts emphasis on how we have to conserve our mature forests, because this plantation here is going to probably take maybe 20, 30 years to really have an impact.
It's been estimated that to reduce CO2 by 1 billion tonnes, you'd need a new forest twice the size of California. But together, could technology and nature suck up the CO2 mess we're currently making?
If we look at planting trees or afforestation, then the feeling was that that could remove something of the order of about 3 billion tonnes of carbon dioxide by mid-century, with carbon capture and storage, which if done right could also be a net carbon removal technology. That might contribute something like 2 billion tonnes of carbon dioxide removal by mid-century, and then direct air capture, something like 3, maybe as high as 5 billion tonnes by mid-century. Now if you add all of those up, you're talking about 10 billion tonnes of CO2 removal by mid-century. That might seem like a lot, but comparing it to our current emissions, which are 35 billion tonnes of CO2, it only represents about 1/3 of the solution. And so that means that to deal with the other 2/3, we need to get much more energy efficient. And if on top of that, carbon removal technologies can help us along the way, then that's great. But let's not pin our hopes on those technologies alone.
Hello and welcome to the Week in Tech. It was the week UK schools paused the use of facial recognition on children to take lunch payments just days after it was introduced. The US revoked China Telecom's license to do business in the States, citing national security concerns. And amid whistleblowers' claims of prioritising profit over safety, Facebook revealed its quarterly profits of $9 billion. That's up by 17% on the same time last year. The world's largest 3D printed neighbourhood, consisting of 100 homes, will be built in Texas in 2022. A cement-like mixture is used to 3D print layers before human builders complete the shells, adding roofs, doors and windows. Car hire company Hertz has ordered 100,000 Tesla Model 3 cars and has partnered with ride-sharing outfit Uber to rent half of these to drivers. The move to sustainable electric fleets starts to hit the road in the next couple of years, though prospective Uber EV drivers will pay around $300 per week to rent their vehicle. And from driving to floating, anchors away, here comes the remote-controlled robot boat, or rowboat. Cruising Amsterdam's canals after 6 years in the making, this plucky powerboat carries up to 5 passengers, goes a blistering 4 miles an hour and uses small cameras to get around the dock with the hope of becoming completely autonomous in the next 2 to 4 years. It was about time.
Plastic is durable, lightweight and cheap. But by 2040, 29 million metric tons of it are expected to enter our oceans each year. That's 50 kilograms of plastic for every metre of coastline worldwide.
One immediate way that we can reduce this impact is to reuse the packaging that we get our takeaways in. And here's an app that hopes to help. Time for brunch. Hi.
Club Zero has just launched across 20 restaurants and cafes in London's King's Cross, allowing customers to opt for reusable containers.
Would you like to use our Club Zero packaging?
Yes, please. There you go.
The server scans your app and any boxes and cups, and as long as you return them, you're rewarded with points and discounts.
Thank you. Well, that certainly feels a lot more solid than disposable packaging, although I have been given a throwaway knife and fork.
It's already available for deliveries via Just Eat. When you're done, cups and lids go in one of these drop-offs.
The QR codes will be scanned so they know that you've returned them.
Each item's reused 250 times before being recycled.
They're also 100% recyclable. The bigger picture of circular economy is not just designing a reusable packaging item, but making sure that the material is also reused.
As for that plastic cutlery,
let's pretend those bits never happened.
But making plastic also requires fossil fuels, using as much oil as the world's aviation industry. So in Finland, scientists are creating entirely new alternatives out of wood.
It's similar to paper made of sustainable wood fibers. It's made on paper machines. It's recycled in paper recycling, but performance similar to plastics.
This is Paptic, twice as strong as paper but 50% thinner and water resistant. It can replace plastic bags, packaging for online shopping and food packets that don't need to be airtight. All thanks to some novel whipping tech.
We can replace 2/3 of water with air. The foam enables us to disperse the fibers much more efficiently, and that helps us to simplify the process. A smaller process consumes less energy, less water.
The big benefit here is that I can recycle this along with my paper waste. And even if I didn't, it would just take several years to break down instead of thousands of years. I can also feel that the bag is stronger than paper, albeit not quite as strong as plastic. Clearly though, this won't be able to replace all kinds of plastic.
But another Finnish alternative does have the tough, mouldable qualities needed for cosmetics or food.
It's almost impossible to guess that these aren't plastic. It's only close up that you can see its natural origins, and that's wood combined with natural binders and dyes.
So our material biodegrades almost exactly the same time period as a same thickness of wood, because the microbes are able to eat our material, and then eventually our material biodegrades into CO2, water and biomass.
Ingredients can be put through existing moulding machines. The material would struggle with housing hazardous chemicals though, and its end of life is proving problematic.
It can be mechanically or chemically recycled. The problem is that the volumes are so small that it doesn't make any sense that the current plastic recycling infrastructure collects and sorts our material out.
So for this to really work, it needs to be scaled, both to bring the cost down, but also to make sure that these materials are recognised for recycling. The technology is there though, and hopefully soon, when it comes to plastic, we won't just have to suck it up.
And Lara assures me that was just water. Right, let's turn from packaging now to what's in the packaging. Producing food is itself not that green. Farming contributes more than 8% of all greenhouse gases.
We are already beyond the boundaries what the Earth can sustain in terms of human population. So we need to be much more efficient in what we do.
And JP may have a solution.
I'm in Finland, just outside Helsinki, but I can't tell you where because this is a super secret test centre where they're taking CO2 out of the air and brewing something rather special. Oh my gosh, you've got to see this. This is bubbling.
In these vats is a newly discovered species of microbe. The bacteria multiplies very quickly. It feeds on minerals, on CO2 from the air and hydrogen, which is also taken from water in the air using electrolysis. And every day, some of it is drained off, superheated, dried and turned into a kind of protein powder that they're calling Solein. This is food that doesn't need vast fields, it just needs a warm, dark place to grow. This pilot project is turning 2 kilograms of CO2 into 1 kilogram of powder every day, and the only byproduct is water, which is also recycled.
We are building the bigger facility, which is in scale, it's 100 times bigger. It will take roughly 2 years, and we also assume that getting a kind of a EU novel food permit, it also takes 2 years.
Food technologist Anna Hekemies has been studying the structure, taste and nutritional value of Solein to create new foods.
So this is it. This is the raw Solein powder. Obviously you're not supposed to eat it just like this, because if you do, it tastes like, well, like flour. What would you have to do with this powder before you can actually add it to food?
Solein can be used as an ingredient in meat replacing products, other non-dairy products, and then also snack products, cereals, and even pasta.
I've been told that you've prepared something that's not the raw powder for me to eat.
Yeah, ice cream.
Ice cream. It's quite appetizing.
Yeah.
I have to say, garnished with a few petals.
Yeah, there's only 4 ingredients, like Solein, water, fat, and sugar.
It's very nice. It's actually more like a sorbet than an ice cream.
It is Italian gelato.
I get paid to do this.
The powder is 65% protein, so 2.5 times more than cooked lean beef. It's also around 15% carbs and 8% fat, with lots of amino acids, vitamins and minerals.
How many people have tried this so far?
Actually, 8.
Wow! So what am I? Am I number 8?
Yeah, you are number 9.
I'm number 9?
Yeah.
So if this does get regulatory approval and it does go on sale in 2023, this could provide an alternative to meat and crops that is climate friendly. And when I say climate friendly,
it's dairy free, which, trust me, everyone in the room will be glad about in half an hour.
there's another cut in emissions right there.
And that's it for the first of our 3 sustainability specials. Next week we are going to be live at COP26 in Glasgow for what should be a very interesting week. In the meantime, you can catch up with us on social media as ever on Facebook, YouTube, Instagram and Twitter at BBC Click. Thanks for watching and get your own ice cream.